If you've been anywhere near the tech world recently, well, you've definitely heard the term microservices.
Oh, yeah, it's everywhere.
It's often sold as the modern way, the
Yeah.
way to build robust, flexible software. But here's the thing, and it's crucial. Just breaking down a huge application, that monolith, as we call it.
Right, where everything's bundled together.
Exactly. Just chopping it up isn't really enough. Doing that without a clear plan, you can end up with, well, kind of a distributed mess instead of something powerful.
That's so true. It's not just about splitting, it's how you split and how those pieces then talk to each other. Without a good structure, you get services that are so tangled up, they might as well still be one big app. That's that tight coupling we worry about.
And that leads to problems, right? Like changes breaking things unexpectedly.
Precisely. Cascading failures. A small hiccup in one service can suddenly take down the whole system. What really makes microservices work, what gives them that scalability and resilience, is sticking to some core principles.
Okay, so that's what we're doing today. A deep dive into 9 essential best practices, the things that turn just a bunch of small services into a genuinely powerful, scalable architecture.
Yeah.
Our mission is to unpack these key ideas, help you understand not just what they are, but really why they're so vital for actually succeeding with this approach.
And this deep dive, it's for you if you want that shortcut, sort of, to understanding what makes microservices effective.
Yeah, cutting through the jargon.
Exactly. We'll give you the key nuggets, the knowledge you need to grasp how these systems are built to be agile, future-proof, without feeling totally overwhelmed by it all.
We'll try and find some surprising bits too, practical things that stick.
Definitely.
Okay, so let's set the stage a bit more. We've said splitting isn't enough. Why are these best practices so important? Beyond just, avoiding a mess. What's really at stake if you skip them?
Well, what's fascinating is that without these practices, you fundamentally don't get the benefits you're hoping for from microservices in the first place. You hit those common traps, the tight coupling, the maintenance nightmares, the scaling bottlenecks. It kind of defeats the whole purpose. Following these practices is what really unlocks that productivity boost and ensures the system works well long-term.
So it turns a collection of services into something cohesive.
Exactly. A high-performing system. It's the difference, really, between having a well-oiled machine and just, like, a pile of parts that happen to be near each other.
That makes perfect sense. Okay, let's dive into the first principle then. This one tackles a huge potential source of that coupling: data autonomy.
Ah, yes. Crucial one.
So the idea is each microservice owns its own data storage. Database per service, right?
Yeah.
No sneaking looks at another service's data directly.
Absolutely fundamental. If services could just dip into each other's databases, well, imagine changing a table in one service.
And it breaks 3 others that were reading it.
Exactly. This principle stops those cascading failures. It means a problem or even just a planned change in one service's data doesn't accidentally bring down others.
Which also means then that each service can scale its data independently. If your user service gets hammered, its database can grow without affecting the order service.
Precisely. Independent scalability is a massive benefit.
But I have to ask, doesn't this make things more complex? Like, if you need data from multiple services for a report or something, how do teams usually handle that without just reconnecting the databases behind the scenes?
That's a really good question, and yeah, it's a common challenge. It often means embracing something called eventual consistency for a lot of cross-service stuff, which, changes how you think about designing some business processes.
Eventual consistency. So
Yeah.
data might not be perfectly in sync across all services at every single millisecond.
Right. For things like analytics, the typical pattern is to build separate data pipelines. These pull data from the individual services, maybe through events or APIs, and load it into a dedicated data warehouse or data lake.
Ah, okay. So the reporting system talks to the warehouse, not the live service databases.
Exactly. It keeps the services autonomous. It's like that analogy. Each service has its own locked filing cabinet. No peeking. If you need a big report, you ask the reporting department, the data warehouse, which compiles the info, rather than you rummaging through everyone's private files.
Okay, that analogy works. It really paints a picture of that independence.
Yeah.
But okay, beyond the data, what about the code itself? How do we stop that becoming a tangled mess? Which brings us to principle 2. Keep code at a similar level of maturity.
Yeah, this one's important.
It's not about forcing everything to be identical. but avoiding that weird mix where some services are shiny and new and others are like ancient relics causing problems, technical debt black holes.
Right. And if you connect this to the bigger picture, having services evolving at wildly different rates, it just creates huge headaches for maintenance and operations. You get inconsistent performance, unreliable behavior across the system.
So the goal is alignment.
Yeah, align the tech stack,
Right.
code quality, security practices where it makes sense, and crucially, be proactive about refactoring older services. Don't just let them linger.
What's the biggest hurdle there? Is it usually technical or?
Often it's organizational, honestly. Getting different teams to actually prioritize refactoring an older service when they're under pressure for new features, that can be tough.
I can imagine,
Yeah.
but the payoff seems big.
Yeah.
Easier for developers, right?
Yeah.
Less weird debugging, easier for new folks to onboard.
Definitely.
It's like that car analogy, trying to fix a car with parts from 1950 and parts from 2025. Just inconsistencies everywhere. Makes fixing anything a nightmare.
Absolutely. And it really cuts down on technical debt. Plus, it improves your overall security posture because you're not stuck with vulnerable old libraries in critical spots.
Okay, so we've got data independence, code maturity. But for a service to be truly independent, it needs its own path to production, right? Which leads us to principle 3, separate builds, independent operations. Each microservice gets its own build, its own repository, build script, artifact. I still have scars from monolithic builds where one tiny change meant recompiling everything.
Oh, you've hit on a really crucial point there. This practice is what directly enables that rapid iteration and deployment people want from microservices.
Because you only rebuild and redeploy what changed.
Exactly. When a service has its own build process, you make a change, you deploy just that service. It doesn't touch anything else, doesn't require rebuilding anything else. This is where CI/CD pipelines really come into their own.
Ah, right. Continuous integration, continuous delivery.
Yeah, you scope those pipelines to individual services. It massively improves efficiency. And maybe more importantly, it reduces the risk of breaking something unrelated when you push an update. Fewer cross-service regressions.
So we're talking tools like GitHub Actions, Jenkins, GitLab CI, Azure DevOps, Circle CI. They're key here for automating that isolation.
Totally. They make it feasible to trigger a build and deploy for just the payment service when only its code changes. Minimizes risk, speeds everything up.
They really facilitate that independent lifecycle for each service.
That's the goal. Continuous delivery for every small piece.
Okay, next up, principle number 4. Clear focus. Assign each microservice a single responsibility. This sounds like the single responsibility principle, SRP, from object-oriented design, but applied at a service level. What does that look like in practice?
It means pretty much what it sounds like. A service should do one thing, one business capability, and do it really well. It should have a clear, narrow, well-defined purpose,
Examples.
like a dedicated payment service, or a notification service, a user profile service. Each handles a very specific, self-contained piece of the business logic.
Makes sense. What's the real challenge here? Is it just deciding the splits initially?
Well, that's part of it, but the ongoing challenge is resisting scope creep. You know, where over time, more and more responsibilities get gradually added to a service until it's not so micro anymore. It becomes a mini monolith.
Ah, right. Got to defend those boundaries.
You do.
And the benefits are pretty clear. Clear ownership, easier testing.
Huge benefits. Clear ownership and accountability, absolutely. Because the code base is smaller and focused, testing is easier, debugging is simpler, maintenance is less painful.
And scalability too, presumably.
Yes, definitely better scalability because you can scale just the services that need it based on their specific load without scaling everything else.
But is there a risk of going too far? Ending up with hundreds of tiny services that become their own management nightmare. There must be a balance.
There definitely is a sweet spot. You don't want services so tiny they're just function calls wrapped in HTTP. It's found through that continuous refactoring and really careful domain modeling we'll talk about later. You aim for services small enough for a single small team to own easily, but not so granular that they create just tons of unnecessary chat between services.
Okay, finding that balance is key. Now, principle 5 feels very practical. Deploy into containers, Docker, essentially. This seems like the standard way to package microservices these days.
It really is. Containers like Docker give you that lightweight, portable, and crucially consistent environment.
Right, consistency is huge.
It encapsulates the service and all its dependencies, libraries, runtimes, everything, so it runs exactly the same way on a developer's laptop as it does in staging or production.
That solves the classic, well, it works on my machine problem.
Precisely. Microservices really thrive here because containers make that dependency management and environment consistency so much easier.
And then for managing lots of these containers across servers.
That's where container orchestration platforms come in. Things like Kubernetes or maybe Docker Compose for simpler setups. They're pretty essential for managing the deployment, scaling, networking, and health of all those containers across a cluster.
So containers are like those shipping containers for software.
That's a perfect analogy. Everything needed is bundled inside, standardized, and you can move them and run them pretty much anywhere consistently.
Okay, now this next one, Principle 6, gets really interesting for performance and reliability. Design stateless services. What exactly does stateless mean here, and why is it so critical?
Okay, stateless means the microservice itself doesn't store any information about the client or the session between requests.
So no user-specific data held inside the service instance itself.
Exactly. Any instance of that service should be able to handle any incoming request, regardless of whether that user has interacted with the system before or even hit a different instance just moments ago.
And the benefit is
huge improvements in scalability and fault tolerance. You can easily spin up more instances under load or kill instances without worrying about losing user session data that was stored inside them.
Because any instance can handle the next request.
Right. If one instance crashes, the load balancer just sends the next request to a healthy one, and it carries on seamlessly because the state wasn't tied to the failed instance. Load balancing becomes much simpler.
Okay, if the service can't store state internally, where does that information go? User sessions, shopping carts, things like that. How do you manage that without making everything stateful again?
Good question. You push the state out of the service, you store it in external, usually distributed data stores.
Like?
Well, maybe Redis for caching or short-lived session data, or a shared database for more persistent state, though you still access it via APIs usually, respecting Principle 1.
And for user authentication or sessions specifically?
Often you'd use things like JWT's JSON web tokens, or maybe rely on an external session management service. A JWT is basically a secure, self-contained token that travels with each request.
So the token itself carries the needed user info.
Yeah, in a verified way. Any service instance can look at the token, validate it, and know who the user is and what they're allowed to do without needing to look up session data stored somewhere else. It makes every instance interchangeable.
That really clarifies statelessness. Cool. Okay, Principle 7. Business alignment through domain-driven design, or DDD.
Yeah.
You mentioned this earlier. This feels like where the tech really meets the business logic.
It absolutely is. DDD helps you design your microservices based on the actual domains of the business. It uses concepts like bounded context.
The bounded context.
Yeah, think of it as a boundary within your business where a specific term or concept has one clear, unambiguous meaning. For example, what customer means might be slightly different in your sales system versus your support system.
So you define separate contexts, maybe separate services for those different meanings.
Exactly. Each service models a distinct, cohesive part of the business domain. It aligns the software architecture directly with how the business is structured and how it thinks. It's about making the software mirror the real-world business operations and language.
So less tech jargon dictating the structure, more the business problem itself.
Precisely. It leads to a more intuitive architecture.
What's the biggest challenge when teams try to actually do this? Finding those bounded contexts.
Yeah, identifying and agreeing on those boundaries can be tricky. It requires deep collaboration between the tech teams and the business domain experts. You really need to understand the nuances of the business language and avoid letting purely technical concerns dictate the service boundaries. And it's not a one-off thing, it's often an ongoing conversation as the business evolves.
Makes sense. It promotes better separation, reduces coupling, because things are grouped logically by business area.
It encourages team ownership too. Teams often end up owning a specific business capability end to end.
Right. Okay, moving towards the user interface. Principle 8. UI modularity, designing micro frontends. So it's not just the back end getting split up.
Not necessarily, no. If you have a significant front end, splitting it into micro front ends can be really beneficial. It allows different teams to build, deploy, and manage separate pieces of the UI independently.
And these often align with the back end services.
Very often, yes. The team that owns the back-end payment service might also own the payment-related UI components in the micro front-end architecture.
That sounds like it could really speed things up, especially for big applications.
Yeah.
Independent front-end deployments. Faster releases?
Definitely. It fosters better team autonomy, reduces the need for massive coordination meetings just to change a button color, It helps scale UI development, just like microservices help scale backend development.
Are there specific tools or techniques people use for this on the front end?
Yeah, there are several approaches. Things like module federation, which is part of Webpack 5, are quite popular. Also, frameworks like single SPA or using standard web components.
Module federation lets different front-end apps share code dynamically.
Right. You can essentially compose a larger application UI from these independently built and deployed smaller UIs at runtime. It's pretty powerful.
Okay, fascinating. Finally, we get to principle 9, service communication. How all these independent services actually talk to each other and coordinate reliably. This feels like the nervous system.
It really is. Getting this right is critical. There are two main patterns people talk about here: orchestration and choreography.
Okay, let's break those down. Orchestration first. What's that involve?
Orchestration is like having a conductor for an orchestra. There's one central service, the orchestrator, that explicitly tells other services what to do and in what order. It controls the flow.
So it makes direct calls to other services.
Yes, usually synchronous calls, though not always. You'd use this pattern when you need tight, centralized control over a complex business process. Maybe the logic is intricate, involves multiple steps, or you need strict transactional consistency across services.
Can you give an example?
Sure. Like, an order placement service might orchestrate the process. First, call the inventory service to reserve stock, then call the payment service to take payment, then call the shipping service to arrange delivery. It manages that whole sequence. Tools like Commanda or Temporal are often used for building these kinds of workflows.
Got it. Central control. What about choreography then? Sounds different.
It is quite different. With choreography, there's no central conductor. Services react to things happening in the system, events, independently.
Events. Like messages being published.
Exactly. A service performs an action and then publishes an event saying, hey, I did this. Other services that care about that event subscribe to it and react accordingly without the original service even knowing who's listening.
More decentralized then.
Much more. For example, when an order-placed event is published, maybe the notification service picks it up and sends an email, and the inventory service picks it up and adjusts stock levels. They both react independently to the same event.
And you use this when?
When you want really loose coupling between services. For simpler workflows maybe, or when you're heavily using event streams with tools like Kafka or RabbitMQ, it promotes greater autonomy.
So it's a trade-off. Orchestration gives you control, but potentially tighter coupling to the orchestrator. Choreography gives you loose coupling, but maybe makes the overall flow harder to see.
That's a great summary of the trade-off. Choosing the right pattern, or sometimes even a mix, depends entirely on the specific business process and how coupled you want those interactions to be. Both are valid, just for different situations.
Wow, okay. That brings all 9 together beautifully. That was quite the deep dive.
It was packed.
We've unpacked these 9 crucial best practices: data isolation, single responsibility, containers, statelessness, those communication patterns. Each one really does seem to contribute to building systems that are scalable, resilient, and easier to maintain in the long run.
Hopefully you now have a much clearer understanding of what makes microservices truly robust and agile when done right. But maybe here's a final thought to leave you with. Given how powerful these practices are together, what kind of unexpected problems might creep in if even one of these principles gets neglected in a real-world system?
That's a good question. Like, what happens if you do everything else right but forget statelessness?
Exactly. Or what if you nail the tech, but ignore the domain-driven design alignment with the business? And maybe taking it even broader, beyond software, where else in your life or work might the wisdom of, say, single responsibility or independent deployment apply? Just something to chew on.